Okay, now we are in a new lesson and we are talking about graphing systems of linear inequalities. So, similar to graphing systems of equations, but how we deal with drawing the lines and how we deal with interpreting the solutions is very different. But if you've graphed a singular linear inequality, and you kind of understand how that works, then you should be in pretty good shape. All right. So let's just kind of jump in and get started with this. So this is systems of linear inequalities. This first one we're going to do. Both of the equations are written for us in slope-intercept form, which I'm personally a big fan of. I think it's the easiest way to graph that's out there, basically. So it says solve the system of inequalities by graphing. So we're going to start with our first equation, which is this y is greater than negative 2x plus 1. So we look at that and we interpret that my slope, so we've got y is greater than negative 2x plus 1. Sorry, that negative kind of will just sort of blend it in there. So my slope is negative 2, and my y-intercept, which is b, right, is positive 1. So let's go over to 1. Let's put our dot there. My slope is negative 2, so that basically means down 2 and then over to the right 1. So we go down 2 from this dot, so we go 1, 2, and then over 1 from there, and that puts us right there. Let's get rid of our little notes there. Put that point back, and then draw your line, right? So you just kind of go okay, and try to get it as straight as possible. All right, not bad. All right, now I don't know if it's gonna let me do this, but this should be a dashed line. All right, it's not gonna let me do that. So let's just do this with a dashed line just right off the bat. And so it's not gonna be perfect, but we're just gonna draw it kind of like so. All right, so this is my dashed line, and if you're deciding, okay, I remember I need to shade these. All right, so you can. There's kind of two ways you can do this. One way that's sort of the cheater way, if it's written in slope-intercept form, is you kind of say, okay, you can sort of shade, if it's greater than, you shade sort of above the line. And if it's less than, you shade below the line. But what you got to do is you have to be careful with that, because sometimes if it's written in different representations, it doesn't always work. So I think the safest bet is always to just use, if you can, use the origin and put that in the inequality and see if it makes it true or false. All right, so if I put the point 0, 0 in this inequality right here, I have 0 is greater than, and then this 0 is out right there. 0 is greater than 1. Well, that's false. So that basically means that all of this right here is going to be shaded. And I'm not going to go too crazy, because you'll see in a minute that we're going to do something a little different on this. All right, now on this next one, right, we got y is less than or equal to x plus 3. So y is less than or equal to x plus 3. So my slope is 1 because there's no coefficient in front of the x, so we assume it's 1. And then my y-intercept is 3. So I'm going to go up to 3. I'm going to put a point. My slope is 1, which means that I go up 1 over 1. So put a point there. You have another one there, another one here. So it's nice slope like this. This is going to be a solid line because it's less than or equal to, right? So here's what we got. And then when I graph this one, right, let's put in 0, 0, because that's this point right here. So if I put that in, I get 0 is less than or equal to 0 plus 3. So 0 is less than or equal to 3, which is true, right? So I would be shading all of this, right? Now, the trick to doing this and to making this a completed and finished product is to recognize, okay, it's a system. So if it's a system, what we're looking for is we're looking for where these have similar solutions, all right? So you look at where are you shading for both of them. And that area where you are actually shading for both of them is, I'm going to highlight it, but is in this area right here, right? So when you do this, you would get rid of, let's get rid of all this nonsense, right? So we know that now that you would shade all of this. And then this would be your finished answer. All of your solutions for this system of equations are going to land in this area right in here. So that's kind of the idea of how these systems of inequalities work. All right, so let's do another one. We can go through this one a little quicker probably. All right, so we got y is less than or equal to 3. Well, I know that's going to be a horizontal line that goes through 3. We've talked about those in the past, but let's just let's get this written here. And it's going to be a solid line, right? So I'm going to put a line right there, and I can actually use that little neat tool that this thing has here. And now for this one, I'm going to, I should be shading this. Just read it. It says y is less than or equal to 3. Well, that means, any of these other y values lower here are good. And it doesn't matter what the x value is. So we've got all this right here is what we've got for this one. And then for the next one here, we've got x plus y is greater than or equal to 1. So you have two choices here. One is you can leave it like this, and you could figure out, well, my x-intercept and what's my y-intercept, because that works best for standard form. And so if you put in, so for your x-intercept, that means y is equal to 0, right? And for your y-intercept, that means x is equal to 0. So for my x-intercept, if I make y 0, I get x plus 0 is greater than or equal to 1. So x is greater than, right? And then for my y-intercept, same deal. 0 plus y greater than or equal to 1, so y is greater than or equal to 1. Right, so this is my x-intercept, and kind of ignore that and just pretend it's like that. Same thing there, right? So x is 1, so we have right there, and then y is 1. So we've got this thing here. So the other thing you could do with this is you could rewrite this, right? You could move x over to the other side and get this written in mx plus b form. So you would have y is greater than or equal to negative x plus 1, which is going to give you the exact same thing. Your slope would be negative 1, right? And then your y-intercept would be 1. Well, that's exactly what we have, right? So this one's going to be solid as well, okay? So we're gonna draw a solid line here, and that's kind of close. It's not perfect, but it's pretty close. I'm not trying to be an artist here. Now, when I graph this, let's put 0, 0 in and see what we get. Well, if I put 0, 0 in x plus y is greater than or equal to 1, I put 0, 0 in. 0 plus 0 greater than or equal to 1. So I get 0 is greater than or equal to 1, which I know to be a false statement. So because it's a false statement, I'm going to shade the other side of it. Okay, so I'm gonna grab a different color here. So let's use orange, right? And so if I use orange, I would go, so everything right here is what I would shade, right? Because that's the other side away from it. So now, because I'm dealing with a system, where are these things the same? So where they are the same and where they share a solution is right in this area right here. Right? So we got all this, and so this is our solution. Is this like wedge that's going to kind of grow as everything heads towards infinity, right? So everything else kind of, that's not what I was trying to do. Everything else kind of, goes away, right? And that's what you're left with, is that blue shaded region. So any point that's inside that blue shaded region is going to be part of the solution set, and there's obviously an infinite number of possibilities for that. So thanks for watching this. The next two videos I make are going to kind of deal with some of the special cases that you're going to get with these.